Hello. Today we are going to talk about what the body does to drugs after you take them. Drugs have to get to the brain. That's the only way they can make somebody feel different. And it's the only way to get high. For drugs to get into the brain, they have to be in the blood, and various factors determine how much drugs get into the blood and the brain, and how long they remain there. Overall, that happens to drugs in the body is referred to as drug dynamics. The first things that happens after you take a drug orally is that it has to be absorbed from the stomach and the intestines into the blood. From the blood, it passes into the brain, and again, all of these drugs have to get into the brain to have an effect. A large fraction of the blood pumped from the heart goes directly to the brain. Drugs that are injected directly into the bloodstream are not absorbed by the stomach but are still passed into the brain. Some drugs, such as an nicotine or enhancers, are absorbed directly from the air in the lungs to the blood. Different drugs have different absorption efficiencies. Some drugs are nearly all absorbed and others are not. The next step is that drugs are metabolized or changed. The metabolism or chemical modification of the drugs can result in the cessations of their action, and metabolism can also enhance the next step, which is excretion. Drug metabolism usually takes place in the liver, but it can take place in other bodily orange organs as well. It's the enzymes in the liver and elsewhere that modify the structures of drugs. An example is the metabolism of ethanol. Ethanol, or alcohol, is acted upon by an enzyme called ethanol dehydrogenases and other enzymes to form acetaldehyde, which is then changed further into acated. Acated is not an active substance, so a metabolite of ethanol is inactive and the effect of taking ethanol or alcohol is dominated by its metabolism. This next example shows the many possible metabolites of nicotine. You can see that it's extraordinarily complicated, and many different kinds of metabolites and chemical structures are possible. Of course, you don't have to remember all of this. I show you this just to give you an appreciation of how complicated drug metabolism can be. In the next and final step in a drug's journey in the body is drug elimination. Drug and their metabolites are removed from the body, mainly in the urine or feces. A couple of important concepts related to drug elimination includes clearance, which is a measure of the body's efficiency in eliminating the drug. And the second is elimination half-life. The half-life of a drug is a measure of the rate of removal of the drug. It's the time needed to remove or metabolize 50% or half of the drug. So, we have discussed three main steps: drug absorption, drug metabolism, and drug elimination. This graph deals with the idea of half-life. It shows the disappearance of two different substances, A and B, from the blood, and they have different half-life. Drug I has a shorter half-life and drug B has a half-life twice that of A. When we look at the levels of these drugs in the blood, which are the solid lines, you can see that one of them curves falls to zero much faster than the other. And that means the drugs A has a shorter half-life. If the half-life is shorter, then the drug disappears faster. Normally, for 97% of drugs to be eliminated from the body, it will take 5 half-lives. But if a drug is taken orally, then the drug has to be absorbed first. It builds up slowly in the blood, which are the dotted lines in the image. After it builds up to its peak, it is then eliminated at a rate according to its half-life. It's worthwhile pointing out that not all drugs are metabolized in this fashion. Ethanol, for example, it's metabolized at a steady rate rather than at a fractional rate. Now I'll introduce the topic for next time. One of the practical impacts of a drug being excreted into the urine is that many drug screens and tests have been developed to screen for the presence of drugs in the urine. It's interesting that sometimes the metabolites of drugs persist in the urine for longer periods than the drug itself. Therefore, in some cases, the targets of the tests can be metabolites of the drugs.